Okay, so I've worked on various automated testing initiatives over the last few years that have failed, and failed for a variety of reasons, such as a culture of manual dev test teams within the organization, and really this big focus on these kind of long-running end-to-end tests that takes hours and days to run, and kind of missing over entire categories of automated testing, such as testing services and isolation, and so forth. So as part of this, I'm going to talk about how we focus our areas of tests on the right categories of tests and the right proportions of each. So how we can test services in isolation, and how we can do integration and contract testing against those components. So this is the type of pipeline we are now building out. And I'm going to talk about the different types of tests we do during this to enable fast feedback, how we deploy services in isolation, and how we test in isolation. So this is kind of like our standard microservice layering. We have dependencies on Kafka, dependencies on databases and cache, and possibly on other microservices, and we may expose REST services ourselves. So unit testing really goes without saying. You know, you're testing the smallest unit possible in a function, and you're mocking all your dependencies and hopefully running tests in parallel to get that fast feedback. Integration tests are probably really slow and problematic when you're testing over a network to external databases and that. So what we do is we bring our external dependencies into the test process itself and use embedded equivalents. And if you're smart with your technology choices and use open source services like Kafka, RabbitMQ, Redis, and so forth, there's a whole ecosystem of embedded tools out there for you to use, and you can get really fast feedback, really good feedback from running against these type of tests. So contract testing, to be able to evolve our services independently, we need good contracts between them. And in a REST API world, that's HTTP requests and responses. And in an eventing world, that's schemas that are produced and consumed from topics or queues. And in consumer-driven contract testing, customers define their expectations against a REST API and as part of their own integration tests and their own pipeline. And this in turn generates these pack files or contract files that producers then pull into their own integration tests in their own pipeline and verify their expectations so they don't break any of their consumers. And it's a great technique to prevent breaking changes from leaking in and keeping your services functional. Schemas like Avro Schema Registry provide a version history of your schemas, and they prevent providers from publishing schemas that will break any of their consumers. So again, another great technique to keep services functional. So if your end goal is to deploy services on Kubernetes, then really you have to be doing all your deployment testing against Kubernetes itself. And don't try to take any quick turns like using Docker Compose or something like this to start up test environments. So Kubernetes is an open source system for automated deployment and scaling and management of containerized applications. And Helm is a tool that facilitates all of that, essentially. So Helm gives us great flexibility to be able to deploy our services to different types of environments, and we can pick the dependencies that we want to use based on whatever environment we're testing against, whether it's in a pull request in isolation or whether we want to deploy entire solutions. So taking this example here in Service A, we're using Helm to replace our dependencies that we can't control, which are Service B and Service C, and replacing them with something like WireMock, which we can control. And again, we can deploy scaled down versions of Kafka. So we can start testing our services in isolation from the likes of Cucumber, where we can control the interactions with our service by putting messages onto Kafka and emulating WireMock. And in Kubernetes, you can run local dev environments using Minikube or Kubernetes for Docker. Draft and Scaffold enable you to push changes quickly to remote repositories. And Telepresence allows you to run services locally as if remotely. And some takeaways: consumer-driven contract testing and schema registries make integrations easier and promote safe schema evolution. Helm charts facilitate rolling upgrades and flexible configurations when deploying to different environments. Embedded tools give you a high degree of confidence by facilitating integration and contract testing early in your pipeline. However, they're never the end goal, and you should always deploy and test your services in isolation on Kubernetes prod-like environments. Thank you for listening.